Most people think augmented reality, AR, for mechanical training is just flashy visuals layered over the real world. But the truth is far more practical. AR exists to deliver the right instruction at the exact moment it's needed, without breaking workflow. Long before AR, engineers relied on manuals, diagrams, and memory. AR simply puts that knowledge into the workspace. To see this clearly, imagine a simple everyday situation where you assemble furniture using a step-by-step visual guide on your phone instead of reading a long instruction booklet. You make fewer mistakes, move faster, and rarely need to reread steps. Without realizing it, you've experienced the core advantage of AR: contextual guidance over static instructions. What's actually happening here is simple. AR overlays digital instructions, warnings, and visual cues directly onto physical equipment. Instead of flipping pages or pausing work to interpret diagrams, technicians see what to do, where to do it, and in what order, in real time. This reduces cognitive load, errors, and training time. Now imagine a real mechanical training scenario, a technician servicing an industrial pump for the first time. With a manual, they stop repeatedly to check diagrams, risk missing steps, and rely on experience they may not have. With AR glasses or a tablet, the technician sees the pump highlighted in front of them. Bolts to be removed glow in sequence, torque values appear at the right step, and warnings pop up if a component is handled incorrectly. Sensors confirm each step is completed before moving on. The technician doesn't learn later. Learning happens while doing, cutting training time drastically and reducing costly mistakes. This same logic is already being used in industry. AR assists in aircraft maintenance, guides assembly and manufacturing, supports field technicians in remote locations, and reduces onboarding time for complex machinery. Instead of replacing expertise, AR captures expert knowledge and makes it available instantly to less experienced workers. The industrial adoption of AR for engineering training has been accelerated by platforms like Microsoft through devices such as HoloLens that allow hands-free, spatially aware instruction in real environments. This shifted training from classrooms and manuals to live task-based learning. In practice, AR-based mechanical training follows a clear workflow: physical task, AR instruction overlay, step verification, error prevention, performance feedback. The engineer or technician remains in control. AR reduces friction, not responsibility. Now that you understand the intuition behind AR-guided mechanical training, the next natural step is to explore AI-driven quality control and defect detection, where vision systems don't just guide humans, they inspect outcomes automatically. And that's exactly what we'll break down in the next episode.